When given a set of data, assuming that the data is normally distributed, the empirical rule states that 68% of the data will lie within one standard deviation of the mean, 95% of the data will lie within 2 standard deviations of the mean, and 99.7% of the data will lie within 3 standard deviations of the mean. So first, what does it mean for data to be normally distributed? So when data is normally distributed, the result on a graph will be perfectly symmetrical and bell-shaped, and the mean and the median will be the exact same value on the graph. So here, for example, say in the data, the mean and the median would be 50. So it goes right through the middle of the data, and the mean and the median is at the top of the bell curve on the graph. Next, to understand standard deviation. So standard deviation quantifies the amount of variation or dispersion of the set of data values. So basically, if there's a low standard deviation, the majority of the values will be closer to the mean. So say the standard deviation was 1, 5, or 10, majority of the data would be closer to the mean. If there's a high standard deviation, the data values will be more spread out from the mean. And for example, down here you can see, so +1, -1 standard deviation, you can see +1, -1 standard deviation is a lot closer to the mean than +2, -2 standard deviation. So using the empirical rule to help you find information about data. So say students scored an average of 80 on a test with a standard deviation of 10. So you want to know how many students got an A, so how many students got equal to or above 90% on the test, assuming that 50 students took the test. So here is a graph of what the empirical rule looks like. So here you can see the middle 68%. So this is where 68% of the data lies, is within one standard deviation of the mean right here in the middle, which is 80, which is given to us. And here you can see the 95% right here. So 95% of the data lies within this range right here, and 99.7% of the data lies within here. So we're trying to find who scored 90 or above. So given that 50% to the left, 50% of the data is to the left of the mean, and right here we see that 34% is within the first standard deviation, we can add 50 plus 34, which gives us 84, and we can subtract that from 100, knowing that all of this together would be 100%. So we get 16% scored 90 or better, which is what we're looking for. We're looking for this area right here. So we know that 16% scored 90 or better. So all we need to do is multiply. We know that 50 students took the test, so we can multiply 50 times 16.16, and we get 8 students. So we know that 8 students got 90% or better on the test. Here is the second part of the example. So using that same data, say you want to know what percentage scored less than 70 on the test. So again, here you can see 68% within one standard deviation of the mean, which is 80. 95% within 2 standard deviations, and 99.7% within 3 standard deviations. So we're looking for 70 or below. So here again you can see, knowing that to the right of the mean is 50%, we can add that to the 34%, which gives us 84%. And then again, we know that this is all together 100%. So 100 minus 84 is 16%. And so that's your answer. You know that 16% of the students scored 70 or less, which is this area right here, because we know that 50 plus 34 is 84, minus 100, which is the total thing, gives you 16% scored 70 or less on the test.